Слушай, ты какую сторону выставил фильтр? Мне надо в сторону, чтобы выставить.
A month ago the Shoshone River, close Yellowstone National Park, abruptly and without notice began bubbling. The waterway changed shading and began to discharge a sulfuric scent on March 25. Geologists and different specialists trust that a segment of the stream situated close Cody, Wyoming had begun to bubble and that another Yellowstone vent opened up. The coming stream has chilled off, at any rate until further notice. Be that as it may, seismic tremor action in and around the Yellowstone supervolcano is allegedly expanding. Inquisitor reports. As Mysterious Universe reports, the bubbling stream close Yellowstone runs only east of Yellowstone National Park. It is sufficiently close to the recreation center and super fountain of liquid magma to be a canary in a coal mine as it identifies with abnormal geothermic occasions. The occasion was at first recorded by Dewey Vander Hoff, a picture taker who recognized the Shoshone River close Yellowstone bubbling and noted other odd elements in the waterway. I've lived here the majority of my life and I've never observed it. It was entirely great. The stream in that spot is a truly dull green. With a polarizing channel it truly flew out. It percolated like flies in a jacuzzi. The Shoshone River close Yellowstone was likewise emanating a poisonous, sulfuric smell, and the extent of waterway that was bubbling like flies in a jacuzzi was a dull green shading. This isn't the first run-through in written history that the Shoshone River close Yellowstone has shown uncommon land action, probably identified with its vicinity to the National Stop and Caldera. Back in the times of Lewis and Clark, a voyager named John Coulter went by the region. The voyager, additionally an individual from Lewis and Clark's epic campaign, trekked to the territory in 1807 and expounded on what he saw. The Shoshone River, close Yellowstone, was referred to then as the Stinking Water River, and as indicated by John Coulter, when he went to the part of the waterway close Yellowstone, he experienced fountains, hot springs and the trademark sulfur possess an aroma similar to a volcanic stream. The range is additionally home to sinkholes, fountain cones, and even surrendered sulfur mines. Regardless of the portrayals penned by John Coulter in 1807, in the meantime 2 centuries, the Shoshone River close Yellowstone has turned into everything except without geothermal exercises. As indicated by Jason Burkhart, a Wyoming Game and Fish Department researcher, the Shoshone River close Yellowstone is presently encountering a break in geothermal movement. We're somewhat in a break contrasted with when John Coulter was here. There was generously more geothermal movement that was happening in those days. Or if nothing else it was, until March 25, when the Shoshone River close Yellowstone started to bubble and radiate the obvious resemble volcanic action. The waterway close Yellowstone National Stop bubbled for 4 days before the movement unexpectedly stopped. The bubbling of the Shoshone River for 4 days in March wasn't the main late geothermal occasion in the waterway to provoke the consideration of geologists. Late action in and around the zone of the waterway close Yellowstone has purportedly sufficiently discharged hydrogen sulfide into the water to make a no-man's land spreading over 1.5 miles. The extent of stream is currently totally without angle because of what Burkhart alluded to as a compound boundary, which is blocking fish from entering. Some trust this to be an awful sign.
I'm Jake Lowenstern of the U.S. Geological Survey, and I'm scientist in charge of the Yellowstone Volcano Observatory. Today we're going to talk about the Yellowstone Volcano Observatory, what it does, who makes it up, and what we do, what are the monitoring techniques that we use to look at volcanic activity at Yellowstone. The Yellowstone Volcano Observatory is a virtual observatory. There is no building. we're a partnership of 3 different organizations. There's the USGS, my organization, which runs the volcano observatories. Then there's the University of Utah, and they run the seismic and ground deformation networks and are doing the geophysics involved with volcano monitoring. And finally, we have the land manager, Yellowstone National Park, and their group of scientists who are out looking at the hydrothermal activity and the other geological activity at Yellowstone. The main systems that we used for monitoring at Yellowstone are the seismic and the GPS ground deformation systems. The seismic system is about 27 different seismic stations. They are spread out all over Yellowstone, and they allow us to look at the size of earthquakes, the timing of earthquakes, and the magnitude, how big they are, how much energy they release. Beyond that, we have GPS stations, and the GPS stations are on very fixed monuments that are put into the ground, and they're averaging their location over many, many days and are taking data constantly. And that allows us to get very precise locations and to see how any spot on the ground is moving over time. And as with the result of having this technique, we can see that the ground at Yellowstone, for example, in this area right here, has moved about 20 centimeters or something around 12 inches upwards over the last 4.5 years. We have 2 primary methods of looking at ground deformation. One we've already talked about, uses satellites and the GPS system, and there we can look at one point in space or one point on the ground and see how it moves over time. We have another technique that allows us to look at all of the ground surface at the same time, and that's called INSAR, or interferometric synthetic aperture radar. In this case, you get 2 radar images that are taken maybe a year apart. And you can't see what happened over that year, but you can see the amount of movement everywhere within the park over that 1-year time shift. We do look at the geysers as well in some locations, but we don't have the data in real time. Instead, we have data loggers which show the temperature of different stream outlets and geyser outflows and pool temperatures, and we can go collect that data and put it in an archive and look at the changes in the temperature of different features over time. Another thing that we have is the park has contracted with various different university groups to fly over Yellowstone and take thermal images of the park. And what they're trying to do with those thermal images is look at how the park changes over time and see if some of the thermal areas are shrinking and other ones are growing. Ever since people started coming to Yellowstone, there have been lots of earthquakes. And ever since we started putting up a seismic network, we've seen that there's swarms. Sometimes there's a swarm every few months somewhere in the park. The biggest one that we know of was in 1985. There's been smaller ones since then. Also, we know that there's been the ground moving up and down over time. Between the 1920s and the 1970s, there was a shift in Yellowstone Lake, and that caused areas in the south to be drowned. And there was about 80 centimeters of upward movement of the caldera floor up in this region. And so we know that there's been this kind of activity. When people have looked at lake levels in the past, they've seen over the past 10,000 years there's even bigger uplifts and downwarps that have been occurring at Yellowstone. So this clearly is the kind of activity that is always happening at Yellowstone. You go around calderas and other places in the world, and we can even find more extreme examples of ground deformation of swarms, also without any volcanic activity. So in general, anytime we see a swarm or we see a bit of ground deformation, we don't necessarily think that this is indicating a volcanic eruption. There's a lot of things that go on at Yellowstone. It's an active place. That's what makes it so special. We don't necessarily tie every single anomalous bit of activity into a volcanic eruption. So YVO includes a couple different people working from the U.S. Geological Survey, a couple people working at Yellowstone National Park, and a group of people working at the University of Utah on the geophysical data, the seismic and GPS data. In general, it's a relatively small operation because there's a lot of volcanoes in the United States. We have well over 100 that have erupted in the last 10,000 years. And so there's a lot of activity to watch. In Alaska, there are about 80 different volcanoes, and probably about a quarter of them have erupted in the last 50 to 100 years. So there's a lot that we need to look out for. Yellowstone is an important part of the volcano program, but it's not the only part. And so we also need to make sure that we have people out looking at the Cascades volcanoes in Washington, Oregon, and California, at the Long Valley Observatory, also in California, and then in Alaska and Hawaii. If you go to our website, which is volcanoes.usgs.gov/YVO, you'll see that we put out a monthly update, and that update summarizes everything that we've seen in terms of the ground deformation, in terms of earthquakes over that monthly period. Anytime anything else happens, there might be a hydrothermal explosion, there's a swarm of earthquakes, there's maybe faster ground motion, we'll put out an information release. And that information release will also get put right there on the front page of our website, and will provide information on what's happening right now. That all goes into an archive, so you can look back at the last 6 months or 9 months or eventually many, many years of information releases and monthly updates, and get a view of what's been happening at Yellowstone over time.